Hi, folks. Wanted to just give everyone an update of what we've been up to in the past year. And I think the biggest news that we have is that OpenACC 3.2 is posted to the website. It was posted, I think, yesterday. And there's a blog post there that explains kind of what we've done. And I've prepared some highlights here. There's a slide for each of these, or at least most of these. But at a high level, the biggest feature, I think, is that we've added support for an error handler. Now, we've made the decision several releases ago to release things on an annual cadence. So not to say these are the features that'll make it and we're going to wait to release until everything is done, because then you just are always going to be pushing things out. But instead, what's ready, we push out as a new release, and what's not ready, we continue to work on. And the error handler is one of these things that we've been working on now for probably at least 2 or 3 releases. We really wanted to get it right. And so I'll talk more about that. The ability to initialize and shut down individual devices with the runtime API. This was kind of an omission that someone discovered and pointed out how useful this would be. And so we've put that in. ACC Wait Any is a new feature for our asynchronous model. And then asynchronous data structures, structured data regions, is another thing that people have asked about. And actually, one of the compilers already had kind of support that wasn't really documented, but it was there. And it enabled us to see, that it was useful, that could work well. And we've since, defined exactly what that means. So all of the implementations can do this. And then we actually spent a lot of the year really reorganizing things. There was many sections where we found that there was a lot of wording that was common between them. And we decided to clean things up. That way, we're less likely to make errors in the future. If we change something in one place and forget to change it in 2 or 3 other routines that share the same wording. So we did a lot of condensing things and reorganize things. And I think it makes the spec a lot cleaner, easier to read, and hopefully easier for our implementers to work on. And then I'll have some highlights in each of those. And I also wanted to raise attention to some LLVM upstreaming efforts that have been going on. So we kicked off almost a year ago a series of meetings with folks who are actively working on LLVM. There's been 2 efforts that were funded through ECP and have been going for several years. One is called CLAC, and one is called FLAC. And you can kind of guess that one is for C and C++, and one is for Fortran. These, now that ECP is kind of beginning to wind down, it was really important that these begin to get upstreamed. And so there's been some community effort around that. We've had several vendors, several universities and national labs collaborating on this. But we definitely, that's just say much more help is still needed, not much more help, but much more help is needed. So if you have any interest, I know we have a few student volunteers, we have folks that are affiliated with universities. If you have any interest in working in compilers or working in open source, this is a great opportunity to work on these. There's a lot of work that's already gone into the runtime that simply needs to be turned into patches and upstreamed. And then there's some room for new features as well. So if compiler development is at all interesting to you, or open source development, I'm sure we can find the right project out of this that would fit you. So go ahead to the next slide, Jack. So the error handler, I would say, is the biggest feature that is in 3.2. So we reused what we already designed for the profiling interface, which allows either a tool or a developer to register a callback and receive events. And this was initially designed for performance, and we were able to reuse a lot of that infrastructure for error handler as well. So I, as a developer, can register a callback and say, I want to watch for errors, or I want to watch these errors in particular. And it will call my callback routine where I could do certain things. Now, the one thing I want to point out that I could not do is recover. There is no error recovery here. We've really, what we found is that for many of our developers, they're running not just on a single node, but most OpenACC programs are MPI programs too. And so we want to make sure that people can receive the error, diagnose the error, and cleanly shut down so that they can move forward without wasting a lot of their allocations and things like that. So from the error callback, you can inspect and diagnose what the issue is. You can call any sort of cleanup routines you may need. It may even be possible, depending on the state of your program, to checkpoint so that you can pick back up from the current state and then gracefully shut down, which for a lot of our apps is call MPI abort. But that's better than having a bunch of zombie processes where one tore down and all of the rest were sticking around. So, but there was a really nice side effect that came from looking at this, and that is that we carefully went through every directive, every runtime call, and looked at what error conditions are there. And in many places, it said a runtime error may occur, which was just a really generic phrase that meant probably your program's going to crash. But we actually went through and looked at, okay, what conditions might trigger errors, and now there's a well-defined structure or an enumeration of what errors there are in the specification, and so we can you can better diagnose why your program crashed. Next.
Thank you.
Next slide, Jack.
Thank you.
Device initialization. This is a little thing, but actually we found that there was, many of my colleagues in NVIDIA were discovering that as we added more and more GPUs to a node, the initialization time kept getting longer and longer. And one of the reasons for that was that we had a runtime call that was just ACC init, and it was all devices of a type. Here I say device default. Now, we did have a way using a pragma or a directive in Fortran to initialize an individual device, but we didn't have that in the runtime. And so what we're finding is that developers were finding their own ways to attempt to work around this shortcoming. And so we decided that it was time to add this feature to the runtime API. So it may seem like a little feature, but now you can actually go through and specify, I want to initialize only this particular device. And on machines with lots of GPUs, for instance, it actually can save a decent amount of time in your setup. So next slide, Jack. Wait Any. This was a direct request from some of our users. Actually, it was some of our climate users in Europe, where they were issuing a lot of worked asynchronous queues, and due to the load balancing features of their application, you could not necessarily guarantee that because work went into the order of queue 0, 1, 2, 3, 4, that it was going to complete in the same order. And so we implemented a way to wait on a group of asynchronous queues, you receive back which one is ready, and then process that. And so this is a feature that exists in other runtimes. In particular, it's very closely modeled after what MPI provides, but it is a nice way to deal with these load balancing or other unpredictable behavior in the asynchronous queues. So this is a new and pretty nice feature here. And this is something that previously you would have to wait for each queue to be completed in order, and so you may end up having lost time if the queue is completed in a not load balanced order. So this is a nice feature. Okay, next up, Jack. And then here is asynchronous structured, I should say structured, not structure, data regions. As I said, at least one of the compilers already had this. And so initially, when we wrote the specification, a Pragma ACC data region was always synchronous. And one of the reasons for that was data allocation. Most of the time, data allocation is synchronous with the host for thread safety reasons and things like that. But what we've discovered over time is there are ways to mitigate that and make this make it possible to do asynchronous data allocation. So then the question is, well, is it safe for the users? Because it's really easy to kind of introduce a data race in your program if these data regions are asynchronous. And we talked to some users and saw some examples of where people wanted to use it and decided that this was worthwhile. So here you can see this ACC data region, it copies in an array A, and I've marked it as asynchronous. Now, the first thing to note is that the region, all of the code inside the region is not asynchronous, but the data operations at the beginning of the region are asynchronous, and the data regions at the end are asynchronous. So you need to make sure that you appropriately synchronize your queues. If you have work that is asynchronous inside this region and it's on a different queue, you need to appropriately wait. But this does introduce some nice patterns for programming, and so I encourage you to try to understand the ramifications of it if you do try to use it. But it is, I think, going to be a useful feature for people. And then I think I have one more slide, Jack, and that is on the LLVM upstreaming. As I mentioned, the CLAC and FLAC efforts, really need some help getting into LLVM proper, into the main line. And so we really would like to recruit your help, and really anything that you're willing to do, whether it's review patches, create test cases. So if you have an application that can be isolated and make a nice test case, that would be great. And so reach out to us, and there are monthly telecoms, although we've not had one in a couple of months now, but we do still keep them on the calendar monthly. And so if you're interested in this, please reach out to me or reach out to feedback@openacc.org, and we'll get you hooked up. So any questions? I saw some things come in the chat. There was Ron asked about asynchronous unstructured data regions, and that already existed. And so this extends the structured data regions in particular. Jose asked, is initialization often in the critical path for this to be required? It really depends on your application. If you're doing a long time stepping simulation, chances are if it takes 30 minutes, you're not going to notice because you're working for hours. But for benchmarking purposes, sometimes even taking a few seconds can be noticeable. And so that's many of our developers found when they were benchmarking that it was nice to have that initialization overhead. And any other questions?
Let's move on to John Levesque and HPE's update.